Hello again. Now we're going to look at solving for the angular speed given the linear speed and the radius. So if you're following along with your handout, we're going to problem type 2, which is I believe the 1 to 3rd page. And actually no, it's a little further along, 4th page maybe. It's actually page 5 of 7. It'll say down the bottom. And we're going to look at number 1. Now for these, remember we have to convert first and then we plug into the formula. Kind of the reverse of what we did with the previous example where we're finding linear speed. We plug into the formula and then we convert it. Here we have to convert first, and I'll show you why. But if we look at number 1, again this is on page 5 of 7, it says you're traveling 60 miles per hour in a car with 16-inch wheels. How fast are the tires rotating in RPMs? Simple enough, right? So we're given linear speed of 60 miles per hour, and we're given an 8-inch radius. If we have 16-inch wheels, that means in diameter that rim is 16 inches, and we're neglecting the size of the tire. So we'll just say the diameter is 16 inches, so you have to cut it in half to get the radius. So we have a radius of 8 inches. Now, step 1, we have to convert our linear speed of 60 miles per hour. The question is, what do we convert it to? Well, 2 things we have to look at. 1, notice our radius is in inches and our linear unit here is miles. We have to convert either all to inches or all to miles. Doesn't matter which, but in this case we'll convert all to inches. So the inches cancel out whenever we go to the formula. But also I'm asking for the n unit to be RPMs, which is revolutions per minute. And right now our time unit is hour. So we have to convert our hours to minutes. So first thing we're going to do is convert our 60 miles per hour to inches per minute. So miles are up top here, so they go on the bottom. And hours are down bottom here, they go up top. Converting those hours to minutes, converting those miles to inches. You have your 63,360 inches in a mile. 1 hour is 60 minutes. Now this is purely coincidence because notice it's 60 here and 60 here. You end up with 63,360 inches per minute. How do I get inches per minute? Miles cancel out, hours cancel out. That's inches over minutes or inches per minute. So we have converted our linear speed to 63,360 inches per minute. Now we're ready to plug into the formula. And we're not solving for V now, we're solving for omega. So we want to use the formula set to solve for omega, which would be omega equals V over 6.28R. So now we're solving for that angular speed. So we have our omega equals our 63,360 inches per minute over our 6.28 radians per revolution times our 8-inch radius. Now one very important thing to keep in mind, especially when using the calculator. You want to type in your 63,360 divided by, but then you have to put an open parenthesis because you want it to do this multiplication before it does the overall division. If you don't put parentheses, it will give you an answer, but it's going to give you the wrong answer. So then you have your 6.28 times 8, close it off, then hit enter. Because again, you want to do this math first before it does the division. Then when we do that, we end up with 1,261.15. Now that's a numerical value and that's fine. But let me show you how we get our units. Right off the bat, you can see inches cancel out pretty easily. But how do we end up with revs per minute? Remember, radians are assumed but not written. And I'm not going to have you guys do this out by hand, but I just want to show you where it comes from. So keep in mind this 1 over minutes, because the inches have canceled out, divided by 1 over revs. And remember, in dividing fractions, you don't actually divide. You multiply by the reciprocal of the second fraction. So that's 1 over minutes times, what's the reciprocal of 1 over revs? Revs over 1. So when you do that, you end up with revs per minute. So that's how this unit gets to be there. So keep in mind, whenever we are solving for omega, you have to do the conversions first before you plug into the formula. And really, if you just do one double unit conversion, that's all you should have to do. You shouldn't have to do any more than that. And once you do that, sometimes you don't even have to do a double. Sometimes you just have to do a single, but most cases you have to do a double unit conversion. Once you have that converted linear speed, plug it into your formula. Remember to keep your denominator in parentheses whenever you're typing in your calculator. Or just go ahead and do that multiplication, then do the division if you want to break into 2 steps. And you get an answer, and the units match up. And that's how you solve for angular speed given linear speed and radius.